All right, we will give folks some time to start trickling in. As we wait, I would like to welcome you all to our fourth and final Git and GitHub workshop. The purpose of this workshop is to give you a quick crash course into how to use GitHub, how to use Git, how to start really working on your projects. I had planned these events specifically for our hackathon participants so that they could get the information they need to start working on their projects tomorrow. But since this seems like such a valuable topic, I thought I would open it up to everyone. So, welcome and hello. All right, let's go ahead and start with a little bit of a screen share here. Perfect. All right. So let's get started. To start, we need a repository to work from. A repository is something you can think of as like a box. It will hold all of your code, your documentation, your images, whatever files you need to make your project work. You can kind of think of it like a folder for everything related to your project. And we're going to go ahead and create one for this event. So let's go ahead and click on New Repository. We're going to be taken to this screen here. There's a few things that we want to look at here. The first is what's called a template. So you can actually create special repositories called template repositories that can hold all of your sort of core files, your README, your license, your code of conduct, all of the files that you would like to use across all of your new projects. If we take a look here, we'll see that I've got a couple of templates that we use at freeCodeCamp, and I've got a couple of templates that we use at DeepGram. However, none of these will really work for the project we're working on today, so we are going to leave this blank. Then we have a section where we can choose an owner. By default, unless you are in an organization view, GitHub will select your personal account to be the owner. In my case, it's Naomi LGBT. However, you can also change the owner to be an organization. As you can see, I've got quite a few organizations here. You'll notice, though, that freeCodeCamp says insufficient permission. This is because we have specific workflows we use to establish new repositories, so we can't just go create them whenever we want. But that's okay, because for today, I'm actually going to put this in my company's organization. Next, we need to decide on a name for the repository. In this case, we are going to call this freeCodeCamp GitHub Workshop 4, because this is now the fourth workshop we have run. Below that, we have an option for a description. This is sort of a very brief summary of what your project is about. Let's give ours example repository for the freeCodeCamp Git and GitHub crash course. Cool. Your description will show up on the homepage for your repository. Next, we have the visibility. So there are two options here. The first is a private repository. A private repository cannot be seen by anybody except those in the organization who have access, or anybody you explicitly invite and grant permission. The other option is a public repository. Now, a public repository can be seen by anybody. They don't even necessarily have to be logged into GitHub. Public repositories are great for open source projects. They're great for situations where you want to have a public issue tracker, you want people to be able to collaborate on your project. Just because your repository is public does not mean I can come along and start pushing code. There are processes for that, and we will go over some of that today. For this workshop, I want you all to be able to see this repository, so we're going to go ahead and make it public. Finally, we have some options here to decide what files we want this repository to start with. Our first option is to add a default README file. The README file can be considered the entry point documentation for your project. Typically, in a README file, you might explain what the project is, you might explain why you built it, you might explain how to use it or how to run it locally, you might talk about how to contribute, you might mention the license. There's a lot of information you can throw in a README. It's good to think of that as the first impression for your project, because the README will be visible on your repository home screen. We definitely want a README for this project, so let's go ahead and tick the box. Our next option is to select a gitignore template. The gitignore is a special file that tells Git not to track specific things. So, for example, if you're working on a Node.js project and you have a Node modules directory, you might gitignore that because you don't need to commit your entire dependency tree to your repository. Similarly, if you're working on Python, you might ignore a venv file or folder for your virtual environment. And GitHub helpfully offers you templates for just about anything you could possibly imagine. Languages, frameworks, project structures, all sorts of options here for kind of the typical things that you would want to ignore. For this project, we do not need to ignore anything, so let's leave this as none. The next option is to choose a license. Licenses are very important because they serve as a legally binding agreement that determines what people can do with your code. They come in all sorts of flavors. For example, the BSD3 clause license, which is what freeCodeCamp uses for our core learning platform, tends to be pretty permissive. You can fork the code, you can modify the code, you can distribute the code, you can change the license, you can close source it. There's a lot you can do with a permissive license like BSD3 clause. On the other side of the spectrum, you have the highly restrictive license, like the GNU Afro Public License, or the GPL, which is very strict in that, for example, if I copy your project and I make modifications, everything I do has to be publicly available as open source under the same GPL license and with the same copyright. It's important to really take the time to explore licenses and decide which one best suits your project and what you want people to do with it. Because say I choose the BSD3 clause license and I work on my project for about a year, and then I'm like, hey, there's actually some potential to make some really good money here. Let's tighten up the license. Let's switch to GPL and let's make sure that folks can't just steal our work and profit from it. The problem with that is a license is not necessarily retroactive. This means that if I have my version of this app a year from now and I license that version under GPL, but I have earlier versions in the source code history licensed under BSD3 clause, you could potentially take that code at that state under that license and use it with those terms. There are some great resources like choosealicense.com. GitHub has some fantastic documentation about it. I strongly recommend taking a look, understanding what decision you're making here. And when in doubt, keep in mind this is a legal document, so if you need extra guidance, I always recommend consulting a proper legal professional. We're not going to license this because we aren't really going to write any code in this project. We're just using this for some examples. So I'm going to leave that as none. Finally, you may have installed applications on your GitHub account. For example, I've installed DeepSource on this organization. It's a code scanning utility, kind of similar to CodeQL or Sonar Cloud. You might also have something that manages your dependencies, like Mind Renovate. All of these will show up here and give you the option of whether or not you want them to access this repository. In my case, DeepSource is installed on the organization and has access to every repository, so I cannot actually turn this off. Which is fine. We'll leave this as is. Let's go ahead and create our repository. When we do this, GitHub will take us to our new repository screen. You can see we've created it under the NH Kerrigan organization. We have the repository name. We see the repository name here. Our description shows up in this About column here. And then we have our README. Because we told GitHub to start this repository with a README, it's done its best to give us something to work with. We have the name of the repository, and then we have the same description. The problem with this is the name of the repository is in kebab case, but the title should be in title case. So let's go ahead and edit this. We can do that by clicking the cute little pencil icon here, and GitHub will take us to an editor. If you've worked with code or Markdown or even something like Notepad, this might look a little familiar. It's a fairly basic text editor in the browser. So let's go ahead and fix this title. We're just going to say freeCodeCamp GitHub Workshop 4. Beautiful. Our title looks great. The problem is we need to save it, and we need to store this change in our repository. To do that, we need to create what's called a commit. A commit can be thought of as a snapshot of your code at a given point in time. Our last commit created the README. GitHub took care of that for us. So it's a snapshot of what that README looked like at that time. We've changed the README, so we need to take a new snapshot. Because we're editing this right here on GitHub, we can do this all by clicking this Commit Changes button. And we're going to get this helpful UI to create our commit. Our first input here is going to be the commit message. The commit message needs to be a clear and concise description of your changes. Every project will have its own style guide for how they want you to write commit messages. At freeCodeCamp, we use the conventional commit standard, so that's what we'll use here. A conventional commit starts with a type, the type of the commit. In this case, because we're changing documentation, this is a docs commit. The type is followed by a colon, and then we write our brief description. Use correct title casing for title. Quick, short, but describes exactly what we changed. Our next field here is the extended description box. And in this field, we can wax lyrical about what we changed specifically, why we changed it, anything that we feel needs to be preserved with this snapshot. So let's go ahead and say GitHub creates the README with the repository name in kebab case. This is not correct formatting for a title, so we needed to update the README to use title case. There's our description. We've explained why and what. Below that, you may or may not see an email dropdown. Chances are you won't see it, because most people have a single email address connected to their GitHub account, and it's the email address they sign in with. In my case, I have a couple of dedicated emails on my GitHub account, one to sign in with, one for my sponsors, and one for commits. My account's email is the email address I use to log in. It is not the email address I want to use to author a commit. So I'll click the dropdown, I'll change it to my commits email, and we're good to go. Our final option is to push this commit directly to our main branch, which is our default branch that GitHub set up for us. We'll talk more about branches later. Or we can make a new branch with this commit and start a pull request. It's a lot of information to cover in there, and we have some extra steps we want to go over. So for now, we're going to commit directly to the main branch. And we'll talk more later about why committing to the main branch is generally not a good idea. For now, we're going to be naughty, and we're going to do it. We commit our changes, and then we can go back to our repository view, and we see that we have our new title. It looks beautiful. We did a fantastic job. It's the best commit we've had all day. If we look above that, we can see our commit message. We wrote docs, use correct title casing for title. You can see that I authored the commit. You see we have two commits because we had the first one that GitHub made for us. And then we have these three little dots. And if we click the three little dots, you see the beautiful description that we wrote. Perfect. Lovely. We're all set. Now, I want to add some more contributing information to this README. But I don't want to do that in the web editor because I want to make bigger changes, or maybe I'm changing multiple files, or maybe it's just not a quick thing and I want to be able to save my progress. We need our repository to be on our local machine. In order to do that, we're going to do what's called a Git clone. Cloning allows you to take a remote repository, such as one on GitHub, and clone it to your local machine. To do this, we're going to click this nice blue code button. And we're going to see a few options here. The first is an HTTPS URL. This URL will require you to use your username and a personal access token, or PAT, to authenticate yourself when you try to do something like push. This is generally considered less secure. In fact, the security concerns were so great that GitHub stopped supporting password authentication. You can no longer use your password. You have to make a PAT, which is effectively an API key for your account. Our next option is SSH. This is a much more secure method because you do not need a personal access token. Instead, you generate a pair of keys. One of them is private and one of them is public. You give the public key to GitHub through their settings, you upload it to your account, and you keep the private key on your machine. And you never, ever, 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 ever give anybody that private key, because that's like your password. Then, in order to authenticate you, when you use the SSH URL to clone, GitHub will say, okay, I see this URL, and this person has this private key. Let me see who they are based on the public key. Does some magic, identifies who you are, identifies that you are actually who you are because you have your private key and nobody else should have your private key, and says you're good to go. The final option is to clone with the GitHub CLI. Now, the GitHub CLI is pretty neat. A lot of things you can do with it. You can clone, you can create issues, you can open pull requests, you can check out pull requests. But as a general rule, I tend to recommend people stay away from it. Not because it's bad, but because it's proprietary. What that means is if you spend your next year learning how to use the GitHub CLI and you're doing everything on GitHub and you barely touch Git commands, and you get a job at a company that uses GitLab or Git or Codeberg, the GitHub CLI will not work with any of those. And since you spent all of your time learning the GitHub CLI, now that you have to use platforms that use Git, you have to learn it all again. If you start by learning Git itself, that'll work across any of the version control providers like GitHub or Codeberg that use Git. So for today's workshop, we will not be going over the GitHub CLI. I have an SSH key set up already, so I'm going to go ahead and use the SSH URL to clone this repository. I'm going to copy the URL, and let's go open a terminal. Now, at the beginning of this workshop, we talked about how repositories are essentially folders. And like anything else, we need to put that folder somewhere. Let's go ahead and make the terminal larger so you can see it. I have all of my repositories for these events I've been running in a folder already. So I am going to change to my CodeCamp Workshop folder. And just so you all can see kind of what's going on here, let's look at what's in this folder. We have freeCodeCamp GitHub Workshop 1, Workshop 2, and Workshop 3. And each one of those is actually a repository. Now we need our fourth one. So to get this, we can do git clone and paste that URL that we copied. We hit enter and Git does its thing. It clones the repository. By default, Git will clone the repository into a folder with the same name. So we see here that we have cloned into freeCodeCamp GitHub Workshop 4. Let's take a look at our directory again. List the contents. We now see 1, 2, 3, and 4. Let's go ahead and change into our new repository directory and do a little poking around. So we can do cd freeCodeCamp GitHub Workshop 4, and let's see what we have. As we might have expected, we have the README file because we saw that on our repository on GitHub. But we also have this special folder called the .git folder. This folder is effectively all of the Git settings for your repository. This folder is what makes our freeCodeCamp GitHub Workshop 4 folder a repository. So everything from where your remote repository can be found on GitHub, to the branches you've made, to your commits, to your tags, to your settings, all of it lives in that folder. Now, it is very, very, very important that you just don't touch that folder. Think of it like the spider that hangs out in the corner of your room above your bed. If you poke it with a stick, it's going to bite you. But if you leave it alone, it's going to do some good for you. It's going to eat some mosquitoes or whatever. And like that spider, this git.git folder will handle all of our Git history and all of our work with Git for this repository. And if we leave it alone, it'll do a great job. If you start poking around in there, you might break stuff. So I generally recommend don't touch it. So we want to start making our changes to our README. Now, we've talked about branches a little. We committed to our main branch when we were working in the web editor. But what is a branch? Consider them to be sort of forks in the road or divergent paths. If we take our default branch, which is main, and we consider that the highway, it has loads of traffic, tons of cars, and everything is going fast. Very risky, very dangerous. When we want to work on something, then we take an exit. We get off the freeway, and we do so by making a new branch. And this new branch can hold all of our work as we work on it, and then when we're ready, we can bring it back into main and get back on the freeway. To create a branch, we're going to use git checkout. Git checkout is the command that allows you to essentially switch what you're looking at, so to speak. You can switch between branches, you can switch between tags, you can check out specific commits. It's a very powerful command. For today, we're just going to use it to create a branch. When we want to make a new branch, we need to use the -b flag to say, make the new branch. So let's add -b, and then let's name our branch. I want to add contributing information to the README, so we're going to call this docs/contributing. We're now on our new branch. Beautiful, perfect, worked great. But are we sure? Are we really sure we're on our new branch? Let's double check. We can double check with git branch. We'll see this new little window pop up, and we will see the two branches that we have. We have the docs contributing branch that we just made, and we have our default main branch. The docs contributing branch is highlighted and has a star next to it because that is the branch we have currently checked out. It's the exit that we're on, essentially. And that's perfect. That is exactly where we want to be. We'll press Q to get out of this screen, and we can start getting to work. Dunzel, to answer your question, I will probably not go over how to make a new key. GitHub has some pretty extensive documentation for setting up SSH, and I'd recommend following it step by step. You also don't want to watch me make a new key because I take a completely different approach from what you would probably want to do. So we have our branch. Saving a file is, you can save a file locally, but cloning is what brings your entire repository down from the cloud into your local machine. And we'll dive a little bit more into what we're going to do with this clone here, because we're going to edit the README again. How you choose to edit it is up to you. You can use Vim, you can use Emacs, you can use Nano, you can use VS Code, you can use Notepad if you're really determined. Because I'm editing a single file, I'll stick with Emacs. And we'll do Emacs to open the README. There's our beautiful README with our title and our description. I want to add a subheading called Contributing. And I will mention that this repository is your playground to explore various Git and GitHub features like issues, pull requests, branches, and more. Beautiful. Now we're going to save the file. And we're going to close our editor. We've made some changes, and we've saved our file. But we haven't actually done anything with the repository yet. Let's see what's going on with the git status command. We will see a couple of things here. It will helpfully confirm for us that we are on the docs contributing branch, and then it will tell us we have changes not staged for commit. We can see that we have modified our README. That all looks correct. That looks okay. But what does this not staged for commit mean? Well, when you are working with Git, there's a difference between saving a file and staging a file. As you work through your project and you're doing your code and you're making your cool feature and you're shipping some bugs, you're saving all sorts of stuff. But when you go to commit it, Git wants to give you the flexibility to say, hey, okay, I have a couple of files that I wrote here just for testing some stuff locally and puzzling through some logic. I don't actually want these in my repository. So the things we do want in our repository, we need to stage for commit. To stage them, we use the git add command. Now, the git add command takes options. You could git add readme md to add just that one file to the staging area. You could git add docs to add your entire docs folder to the staging area. Or you can git add dot to add everything to the staging area. Now, you will hear people warn you not to use git add dot. The primary reason for that is if you've decided that Naomi has no idea what she's talking about, and you're going to go move that git directory we talked about earlier, you could end up in a situation where your entire documents folder on your computer is a Git repository. And if you do git add, next thing you know, you're committing your tax forms. Not great. Good way to get your identity stolen. Let's avoid that. Thankfully, we've used git status to look at what changes are currently visible in our repository. We see that we've modified the README. We know that's the only thing we've modified. That looks correct. We can safely say, let's do git add dot. Now, let's go ahead and look at our status again. Again, we see on branch docs contributing, but now we see changes to be committed. That looks correct. We wanted to stage our README changes. We're ready to commit. We're going to use the git commit command. And there's a couple ways we can do this. The first is to pass the -m flag. And the -m flag allows you to write your commit message right here in the terminal. So we might write docs add contributing information. And we could make a commit just like that. I generally prefer not to take this approach. And here's why. If we use just git commit, we don't give it anything else. We just say git commit. Git will open up. Hello? Where did it go? Are we putting technical errors today? There we go. Git will open up a new terminal with a file. This file is our commit file. So let's take a look here. We have a bunch of lines that start with a hash or a £, or an octothorpe if you're a language nerd like I am. These are comments, and Git has automatically inserted some of these to help us understand what we're doing. Anything that starts with a hash will be ignored. It will not be included in the actual commit. Git helpfully tells us, hey, things that start with £, not in the commit. But then it tells us we're on branch docs contributing, so we can make sure that we're committing to the correct branch, and it tells us what we have ready to commit. This is why I prefer to do git commit and write my message in this file, because this gives us one final chance to look and say, okay, the things included in this commit are the README, and we expect the things in this commit to be the README. So it's one last chance to really check and make sure that everything looks great. Now, we need to actually write our commit. The first line of this file will be your commit message. So it will be the equivalent of the smaller input box that we saw in the web UI. This is where we would write something like docs add contributing information. After this line, if we add more space here, anything after the first line becomes the extended description. So it becomes this stuff that we wrote in that bigger field when we were making a commit on GitHub directly. For this, let's go ahead and put something silly. We're going to say we found a spider in the corner of our room. Do not make actual commits like this. We're having a little bit of fun because we're taking some opportunity to learn some cool stuff. But if you start writing commits like this in an actual project, you're going to have some problems. For now, this works for us. If we save the file and close it, Git says, okay, you're done writing your commit, and creates the commit. Now, this commit is only on our computer. It's not on GitHub yet. In order to get it on GitHub, we need to push it up. And we do that with the git push command. Now, by default, if you run git push with a new branch like we have here, Git will complain that it doesn't know where to push the branch. I would demonstrate this, but my Git configuration is set up so that it just figures it out. But if you see an error that it doesn't know where to push, you need to set the upstream for the branch. And you do that with the -u flag. And then you provide what's called the remote name, which by default is origin. And I'll show you what that means in a minute here. And then you provide the branch name. Now, if you try to push, say, to a branch with a different name, Git might complain. Let's say docs contrib. Git's going to say no, because it doesn't match any known paths. When you set the upstream, you actually need to use the same name as your local branch. Now we've pushed. Ta-da! So if we go back to GitHub here, I knew I was going to click the wrong one. We see GitHub telling us that our new branch has had recent pushes. Before we get into that, let's take a quick peek back at our terminal here. I talked about a origin remote, but what does that actually mean? Well, the remote repository is the repository in the cloud. In this case, it's our repository on GitHub. When we clone a repository, Git sets up a remote URL so that it knows where to put changes when we want to put changes back in the remote. By default, the name for that remote is origin. But we can take a look at the remote configurations we have with git remote. This only tells us origin. I don't know about you, but I don't think that's very helpful. Let's see if we can get some more information out of Git with a V flag for verbose. Now we see some more information. We can see we have an origin remote, our SSH URL that we use to clone, for fetches, and again for push. That's how Git knew when we said push to origin docs contributing, it knew what origin was and where to find it because it set up a remote for us. Sometimes you may want another remote. For example, when I work on freeCodeCamp, I work off of what's called a fork. Essentially, I have my own copy of the entire freeCodeCamp repository where I do my work. But sometimes my copy gets very far behind from the real freeCodeCamp. In order to help me keep up with that, I might add the real freeCodeCamp as another remote. I might call it upstream. Let's try adding one now. We'll do git remote add upstream, and then you would provide the same sort of URL that you would get when you try to clone. In this case, let's set our upstream to GitHub Workshop 3, just so we see something a little different. If we take a look at git remote v again, we'll now see our origin remote, which points to Workshop 4, and our upstream remote, which points to Workshop 3. Beautiful, great. If we wanted to get into keeping things up to date, we've done the first step, but we aren't going to cover that today because we just don't have that much time. So, one second here. Okay. Let's go back to GitHub. We take a look at GitHub, and we just pushed to our branch. So GitHub is saying, hey, you pushed to this branch, maybe you want to make a pull request. And we do. But what is a pull request? A pull request is your way of saying, hey, I have some changes I want you to look at, accept, and pull into the main branch. Hence, pull request. Let's go ahead and create one now and see what that looks like. We're going to click this compare and pull request button. And we're going to see this wonderful new UI. The first thing that I want to point out is this little section here. There are two key components here. We have what's called the head branch, which is where our changes are coming from. In this case, docs contributing. And then we have our base branch, which is where we want the changes to end up. The base branch is the freeway. Our head branch is the exit we took, and now we're wanting to get back on the freeway. So our base should be main, and our head, or compare, is docs contributing. That looks perfect. Now we see this lovely little UI over here telling us that this is our first pull request and we should read documentation. This documentation doesn't exist yet because we haven't written it, so let's just close that. Let's get that out of our way. Then we can see our actual pull request form. The first thing we see is a title for the pull request. Every project, again, will have different standards they use for how they want you to write your titles. In this case, because we have a single commit on the branch, GitHub has decided, hey, maybe you want to use the commit message for your pull request title. If we had multiple commits, GitHub would say, yo, clearly you want to use the branch name for your title. Never in my life have I used a branch name for a PR title, but someday someone has to because GitHub thinks it's the right thing to do. For this, I think our title is perfect. It follows our conventional commit standards. It's a nice descriptive title. It works. Next, we have the description. Kind of like how you have a description for a commit, you can have a description for a pull request. This is your place to talk about why you are making these changes, why you think they should be accepted, what you changed, why you took certain approaches. This is kind of your stand up and explain your thoughts. Again, because we have a single commit, GitHub has decided that our extended description from that commit would make a great pull request description. I happen to like screaming about spiders, so I think we'll leave this as is. Over on the right here, we see a few options. The first one is reviewers. This is where you have the option to select specific people or specific teams you want to look at your changes. In bigger projects like freeCodeCamp, we might have configuration that automatically requests reviews from our core dev team. But maybe, I've been working on this feature and I've been asking Jessica a lot of questions about how I should tackle this feature. And Jessica's given me a lot of great advice. And I want to make sure that I'm on the right page here. So I might include Jessica in this reviewers by putting her GitHub name in the box. This would specifically notify her that, hey, I want you to look at my pull request. The caveat to this is it's important to remember that most open source maintainers work entirely for free or for tiny little donations, and they're doing this kind of thing in their spare time while they work a regular job to keep a roof over their head, and the lights on, and the power so you can write more code. So you really want to do this sparingly. You do not want to be out there hammering review requests at every single maintainer of a repository, because you're just creating a lot of extra noise, you're slowing things down, and eventually they're going to block you from their projects. We're going to leave that alone. That's perfect. Now, because I own this organization, I have admin level access, which means I can assign specific people to the pull request, I can add labels to the pull request, I can add it to projects, and I can add it to milestones. If you're contributing to somebody else's project, chances are you won't have the permissions to set any of those. And they may have some labels that they automatically apply or assignees that they automatically apply. So it's okay to just leave them alone and let whatever the maintainers have set up do its thing. If we scroll down now, we get another chance to take a look at our changes. Our first section here tells us we have one commit for this pull request, which is correct. We only made one commit. We have a single file changed, which looks correct. We have only changed the README. And we have a single contributor, because I am the only person who pushed to this branch. Now, if I was working on my feature and I said, hey, Jessica, I really need some help with this. I'm stuck. And Jessica says, hey, I know exactly what to do. Let me push the fix to the branch for you. Then we would have two contributors because both Jessica and I would have authored commits that exist in this pull request. Below that box of cool little metrics, we'll see the full commit history for the pull request. Not much to see here because we have one commit, but we can take a look and see that we have docs add contributing information, and that we have our description about finding spiders. Perfect. That looks great. And then finally, we get a chance to take another quick peek at the changes we have made. We can see here what's called a diff. It essentially shows the difference between the files already on main and the files on our branch. On our branch, we've added a few new lines to the README with contributing information. We can see here ++++ for the new lines, our contributing header, and our contributing description. Beautiful. That looks great. Let's go ahead and open the pull request. And we do that by coming back up here and hitting the Create Pull Request button. We now have a beautiful pull request. Now, let's say that we want to review this. We want to make sure that the changes are good. We're going to pretend to be Jessica here, and we're going to review this pull request. So we go to the files changed, and we take a look, and we see that Git should be capitalized because it is a brand name. The command is lowercase, but the actual name should be capitalized. So we want to suggest that this is fixed for this pull request. To do that, we can click the cool little plus button here. We'll get a box to leave a comment, and then we can click this plus minus here to add a suggestion. GitHub will fill in a special suggestion code block with the current contents of the line we selected. If we head up here and we capitalize this G, we can go ahead and add a suggestion comment. We're just going to add this one comment. So we'll click Add Single Comment. And then we see this really cool little UI that shows the actual change we are suggesting. We can see that the line is removed, and then the line is added again, and we see highlighted the difference between what exists and what we want to exist. And we can see that Git has been capitalized. Now, after Jessica has come and reviewed my pull request and made lots of great suggestions, I want to just add them. I want to accept them and add them to my pull request right there. And we can do that by using this Add Suggestion to Batch button. Now, since we only have one suggestion because this is a very small pull request, we could just use commit suggestion, write a commit, and accept this proposal. When you're working on larger changes, you might have multiple suggestions. And if you commit every single one of them individually, you're going to create a lot of noise. Additionally, if you're working on a repository like freeCodeCamp, where we have automation to run things like our tests and our formatting, every single one of your commits is going to trigger one of those workflows, and it's going to take forever to process all of them, and that delays the rate at which your pull request can be reviewed and accepted. So we want to do it all at once. We want all of our suggestions at once. Let's go ahead and add another suggestion here. Let's say we want to put a little line break in there so we have some better spacing so it's easier to read. Whoops. This time we're going to do a proper review. A proper review would allow you to post multiple comments all at once. We've only got one comment, that's okay. But we have some options for how we want to process our review. Now, because this is my pull request, some of these options aren't available to me. I cannot approve my own pull request. But Jessica could say these changes are great and mark the approval and say, I'm signing off that this pull request is good. Or if she's got suggestions like the one we just made, she might request changes. That says, whoa, this pull request is not ready yet. Let's stop, take a look at some things, fix some things, and try again. We can't do either of those because we made the pull request, so we're just going to make a comment. We'll hit Submit Review. Our comment will get posted. Beautiful. But our Add Suggestion to Batch button is grayed out. That's because in this conversation view here, you can't actually batch your suggestions. So we need to go back to the Files Changed tab, and we're going to scroll down here, and we're going to add this to the batch. Then we're going to scroll down and add this to the batch. Then we can go back up here and commit suggestions, maybe. Did this to me last time too. I don't know why. But you would get the same UI here where you would write your commit message and your commit description. And we're just going to put chore accept review changes and hope that works. And let's put a cute little smiley face. And then commit it. We've now made a commit that included all of those suggestions. So let's go back to what our pull request looks like here. We can see we have a new commit, chore accept review changes. We've got a description with a cute little smiley face, and everything is good to go. If we take a look at the file changes now, we see our new line, and we see Git is fixed. Beautiful. This pull request is ready. Let's go back to our conversation tab, and we can hit merge pull request. We get yet another option to write a commit. This one is our merge commit, which is created when we merge the pull request in. And for this, whatever GitHub's default is, good enough. We'll double check we have the right email, and we'll merge it. Now, we're done with this branch. We've merged in the changes, we're good to go. Let's get rid of it. We don't want it anymore. We get a nice little button to delete the branch. Let's head back to our code tab here, and we will see our changes now live on the README, and we can see that we have our merge commit. And if we click here and take a look at our history, we'll see the commit that we wrote. Beautiful. Everything looks good. We're ready to go. But these changes are only on GitHub, which means the main branch we have on our local clone is now behind. How do we fix that? Well, let's go back to our terminal. We are still on the docs contributing branch, and we're going to double check with the git branch command. We can see that the star is at docs contributing, so we're still on that branch. We'll press Q to get out of this, and then we're going to git checkout -b main. And we get an error because the main branch already exists. So when we want to check out a branch that already exists, we get rid of that B flag, and we write git checkout main. Now we're on our branch. But I don't believe Git. I think it might be lying to me. So let's go ahead and check again. Let's take a look at git branch. And now we see the star and the highlight have both moved down to main because that is the branch that we checked out. That looks great. It's beautiful. We're ready to go. We'll press Q to get out of this. But our main branch is still not up to date. We've accepted a pull request on GitHub. The main branch on GitHub has the commits from that pull request. We don't have them here. So how do we get them? Well, we run git pull. And just like that, it pulls down our changes. Now, if you remember, earlier we pushed our changes up to GitHub, and now we've pulled our changes down from GitHub. So we push up and we pull down. Git push puts it up on GitHub. Git pull pulls it down from GitHub. Our main branch is now up to date. We're great. We're good to go. But we still have that docs contributing branch on our computer. And if we just leave that there and we keep leaving our branches there, we're eventually going to have so many branches that we can't think straight. Instead of a freeway with some exits, we're going to have the New York City subway. And we don't want that. So let's go ahead and delete the docs contributing branch because we're done with it. We can do that with the git branch command. We pass the D flag, and then we say the name of the branch, docs contributing. Git will tell us it's deleted. Let's take a look at git branch again just to be sure. And now we see just the main branch. It's got the star and the highlight because that's the branch we checked out. Sometimes you may be trying to delete a branch that hasn't been merged yet. And Git will try to warn you and say, hey, are you sure you really want to do this? Because you might be losing your work. It'll get extra aggressive if you haven't pushed your work either. So it wants to really make sure that if you delete a branch that has changes, you understand that it's gone and that your work could be gone. Sometimes that's what you want. Sometimes you make a branch to play around with a feature. The feature sucks and you just say, okay, tabling that idea, throw the whole thing out. We'll try it again in a year. So you want Git to delete the branch knowing full well that you're throwing that work away. And that's okay. To do that, instead of a lowercase d flag, you would pass git branch with an uppercase D, which forces the deletion of the branch. Again, it is very important to do so carefully so that you don't accidentally delete your hard work that you wanted to keep. We don't have that branch. We don't need to delete a branch. So we're just going to exit. And we'll go ahead and clear our terminal too. Now, let's go back to GitHub again. Sometimes you want to be able to track your ideas or track bugs or, keep your thoughts organized. And the best way to do that is with GitHub issues. You can think of an issue as like a ticket for some work. Maybe it's an issue that includes a bug report. Maybe it's an issue with a feature request. Maybe it's an issue with questions about how to use your app. Issues are sort of your bread and butter for project management. Let's go make an issue. We're going to click the Issues tab. We do not have any issues currently, so let's make a new issue. We only have a couple of options here. We can either make a blank issue, or we can report a security vulnerability. Now, I'm 99.9% sure that our repository with a single README file does not have a security vulnerability, so I'm going to use a blank issue. We're going to click that button. And we get a UI that was kind of similar to our pull request. We need a title for the issue, and we need to write a description. Now that menu that we saw pop up that only had 2 options, we can actually do some more really cool stuff with that. We can create templates. Now I think that's a great idea, and I don't want to forget it. So I'm going to log that as an issue, so I have a ticket for the work. So we're going to say create issue and PR for pull request templates. And then for our description, let's put some money in here because we like money. Again, we're having a little extra fun because we're here learning and exploring GitHub. If you open an issue like this with a bunch of $signs on freeCodeCamp, I will have to block you from our organization. And that will mean you can't open issues, you can't make pull requests, you can't interact with our software. I really don't like doing that because I think you are all lovely people. I am quite fond of you, and I would love to see you contribute. So, use a demo repository like this one for your practice and save the large actual projects or even the small actual projects for your legitimate issues and pull requests. This is a demo repository. Let's go ahead and create a money issue. Now, I want to work on this issue. So, oh hey, it took all my dollar signs away. I guess that must be a markdown formatting or latex. Maybe it's parsing it as latex. Our money went away. GitHub stole our money. Oh no. Anyway, let's go ahead and start working on this issue. We're going to go back to our terminal, and we want to create a branch for this work. So we're going to git checkout b feat templates. Beautiful. We're on our branch. I'm pretty confident because I have my terminal tell me just to be safe, but we'll go ahead and double check. And let's pretend Naomi can type. We can see our new feat templates branch with a star and the highlight. So we are on that branch. Let's press Q to get out of here. Now, we're going to edit a few files today. And when I'm editing multiple files or I'm making larger changes, that's when I get out of the terminal editor and really want to do the work in my full IDE. In my case, I use VS Code, and I have my system configured so that I can type code and get my editor. Let's get our terminal out of the way here because we can use the one built into VS Code, and then we'll make things bigger so that you all can see it. Now, let's talk about templates. We can actually create issue templates that sort of help someone know how we want them to request a feature or how we want them to report a bug. We're going to do both of those today. But first, we need somewhere to put them. If you remember that .git repository, or goodness me, it's getting late, the .git directory, that's the special folder that holds all of the settings for Git. We want a .github folder, which similarly will hold all of our setting and configuration for GitHub. So let's go ahead and create that. We're going to do a new folder. We're going to call it .github. Beautiful. So let's go ahead and start with our issue templates. Now these need to live in a special folder inside our .github folder. They need to live in an issue template folder. But you can't just write issue template. No, you have to scream issue template. So let's get to screaming. We need to call the folder issue_template. Beautiful. We now have a folder. Since it's the only thing in there, VS Code collapses it for us and gets it out of our way. Inside this, we can write our templates. We're going to start with our feature request. So I'm going to create a new file. I'm going to call it feature request.md. We're making another markdown file. To spare you all from having to watch me type everything by hand, we're going to go back and we're going to steal the stuff we did this morning. So let's go back to repositories, workshop 3, GitHub, issue template, feature request, copy, paste. And now we can look at this file. At the very top here is something called front matter. You may have seen this before if you've done things like poke around at our curriculum files at freeCodeCamp, where we use front matter, or maybe you've worked on a blog in Next.js where your markdown files also need front matter. Front matter is effectively the way that you set properties for your document. These properties use what's called YAML syntax, or yet another markup language, and we'll dive more into YAML in a little bit. But for now, let's take a look at what we've got. We've defined a name property of feature request, and we've defined an about property that says suggest an idea for this project. That's our description for the template. That's our name and description for our template. Then we have this title property. Now, if you remember when we made our issue, we had the option to create a title for our issue. This property allows us to pre-populate that input with a specific value, in our case, a feature tag. Then we have an option for labels. We're going to automatically apply the enhancement label to every feature request. Then we have our space for assignees. We're leaving that blank because I don't want to assign myself to every issue and get my notifications blown up. We can tell where our front matter starts and ends by our 3 dashes. The first to start the front matter, and the second to end the front matter. Below that is where we get into our markdown content. Everything that is in this markdown will show up in that description box when somebody uses our template to open an issue. So we have headers. We ask for the user to describe the feature, why they want the feature, what they think is the best way to add the feature, any alternatives, additional context. It's a beautiful template. We also add some comments here to help give the user more instruction. These comments won't show up in the final issue. They're kind of like HTML comments. You can write them, and they're there in the code, but they won't show up on the web page. This looks great. We're going to go ahead and leave this as is, and let's start on our bug report. This time, we're going to use something way cooler than a markdown template. We're going to use a YAML file to define an issue form. An issue form, unlike a template, gives us some extra control over the type of information we ask for, and we can require specific things to be filled out. So we're going to name this bug report.yml, whoops, not reportee, report.yml, or YAML, but who wants to type an extra letter? We'll do YML, and create our new file. Again, I'm going to go steal the one we already wrote, because it's a lot to type out otherwise. We're just going to sneak over and copy that real quick, and pop it on in here. This is going to kind of look like the front matter, because the front matter uses YAML syntax. We have our name property, which is where we set the name for the template. Our name is totally fake. Our code doesn't have bugs. There's no way. But maybe it does. We did see a spider earlier, so maybe it's, I found a spider. Now, in our Markdown template, the about property was used to set the description for the template. In a form, it's just the description property. So let's come up with a description. It caught me in its web, and now I can't get out. Perfect. Below that, again, we have a title property, so we can pre-populate the title field. We have a labels property, which we have a list of 2 labels to automatically assign to the issue. And then we have our assignees, which gives us a list of people to assign to the issue. Now, it's important to note here that both labels and assignees are a list. Labels uses the syntax that might be kind of familiar if you like JavaScript, for example, and you use an array or a Python list. Assignees looks more like a markdown list. Generally, these are interchangeable when you're working with lists of just string values. But we're going to get into this body property here, and we have to use the markdown style formatting because we're not doing lists of strings, we're doing lists of YAML objects. So let's look at our body. The body property is where we can define the fields that our form should have. Our first one is a markdown field. A markdown field just displays text to the user that they can't edit. It's a great way to add instructions for how you want them to fill out the form, or any other information you want to convey that isn't going to end up in the final issue. We'll leave this as thanks for taking the time to fill out this bug report. Below that, we have a text area. Like an HTML element, the text area allows us to accept long-form responses. Multiple lines, multiple paragraphs, plenty of room to describe, in this case, what happened. The label will serve as the title for that input, and then the description appears below the title as some informational text. Like an HTML input, we have a placeholder value, which is what will show up when the input is empty. We can also define a pre-populated value, which will be filled in for the user automatically, but they can always remove or change it. Then after our attributes, we have validations. And here we can say, this text area asking what happened is a required field. The user cannot submit the issue without filling this out. That's great. If you notice, each list here has multiple things. That's because our little hyphen here indicates the start of a new list item, and because we're using this markdown syntax, we can create a list item with multiple properties and values. So let's scroll down to our next list item. This one is a drop-down field. It kind of behaves like an HTML select, but you also have the option to let the user choose more than one. We again have our label, which is the title for the input. We've set the multiple property to true, which is what will allow the user to select multiple values, and then we define our options. We're asking about what kind of browsers the user is seeing the bug on. So let's go with the most common browsers: Firefox, Chrome, Safari, and Microsoft Edge. Beautiful. That's a good little select menu. Then we have another text area. This one, we ask them to share any relevant logs, so there might be some errors. We got a lovely little description here that's cut off because our text is big, so let's get our files out of the way. We can see that it's automatically formatted into code, or so we say. But is it? It is, because we set this render property to shell. That tells GitHub we want this rendered as a multi-line code block with shell syntax highlighting. We'll take a look at what that actually looks like in the end result here after we're done with our work. Finally, we have our last item, which is checkboxes. Like HTML, this allows us to define various checkboxes in a list, and users can tick one, none, all, some. In our case, we've given this section a title of code of conduct, we've written a description that you agree to follow the code of conduct, and then we've added our options. Our first checkbox has a label that says I agree to follow this project's code of conduct, and we've made it required. And that's it. We have a checkbox list with only one checkbox because there's only one thing we want the user to check off. So, that looks perfect. Let's save it. Let's open up our files again. We now have our two issue templates, but we need a pull request template. Now, a pull request template, unlike an issue template, can't go in the issue template folder. Even though a pull request is an issue behind the scenes as far as GitHub is concerned, the distinction is important here. So let's go ahead and make a pull request template. The pull request template will go directly in our GitHub folder. We're going to call it pull request template, and again, we have to screen because GitHub likes screening, and honestly, so do I. So we're going to call it pull_request_template, and this will be a markdown file. Because despite, several attempts at begging them, especially at the maintainer summits, GitHub has not added support for pull request forms. Some other providers, like Gitty, which is what I use for my own company, do have pull request forms, and now I've been spoiled, and I think they're the one way to go. But we can't do that here, so let's go ahead and do a Markdown template. Now, kind of like the issue template, kind of similar, except there will be no front matter here. We're just going to shove some Markdown in this file. We're going to go borrow some again. We're going to sneak and take that, okay? And we'll just pop it right on in here. And this is just a checklist. We have a comment that tells our users to put an X in each box. We have a checkbox that says they followed our contribution guidelines. We have a checkbox that says their pull request targets main as the base. And we have a checkbox that says they tested the changes locally. Then we tell them to indicate if it closes an issue. And I'll show you what that looks like specifically here in a minute. This looks like an okay pull request. Honestly, I stole it from freeCodeCamp and tweaked it a little bit. Let's go ahead and save it. Now, we do have quite a few files here. So we're going to open up the terminal and see what Git thinks. And let's just make it big. And give me just a second here. Sorry, it is like 9:30 at night now, and I have not eaten anything, so I need to slap in a dinner order real quick. Why can't I put onions in there? Good enough. Okay. Perfect. Okay. Good enough. Hope I didn't screw something up. All right. So we look at our terminal here, and let's take a look at our Git status again. This time, we've added an entire new folder, and Git has never seen this GitHub folder before. It has no idea what's going on. So as far as it's concerned, there's a new folder. It's new, so it doesn't care what's going on in that folder. It just knows it's there. Let's go ahead and open up our file tree again, and we can take a peek here at VS Code, which helpfully tells us that our 3 new files here are untracked. That's what the U means. This means that they are new, and GitHub or Git has not started tracking them at all yet. Kind of like our changes to the README, we want to stage these in order to get them ready for a commit. We talked about using git add dot. Let's go ahead and explore adding individual files. So let's go ahead and git add GitHub pull request template MD. We'll see over here that the U changed to an A, which VS Code is helpfully telling us that the pull request template is added to the staging area. And if we look at our Git status, we now see changes to be committed, the new file. Now we've added a file to the staging area in that GitHub folder. So that GitHub folder has now started to be partially tracked. Git now says, oh, hey, there's stuff in there. Maybe I want to care about that. It says the pull request template I really care about because you told me to add it. And it says, but there's this other issue template folder. That's new. I've never seen it before. I don't care. So it just shows us untracked the entire issue template folder. Let's go ahead and add it. And we're going to add it individually with git add.github/issue template. Now we'll see both of the files in that folder have changed to A for added because we added the entire folder at once. That's how you can use git add to specifically choose what you want for a commit. This is really helpful, I find, when I'm doing things like working on a large feature that has multiple moving parts. And I make enough progress that one of the parts is working great, but I got changes all over the place to make other stuff work. I can add the individual files that specifically relate to that one moving piece and create a granular commit. And I can continue to do so as I get little individual pieces working. Then I have a pull request with a really nice, clear history. We've got everything added now. Let's take a look at our Git status again. Now that they're all added and effectively being tracked, Git says, oh, hey, there's 3 files. We care about those 3 files, and they're ready to be committed. So let's commit it. We're going to call this feat add templates. We're going to save it, close it, and get pushed. Let's go take a look at GitHub again. If we go back to our proper repository, hey, there's a $sign now, and we go back to code here, we'll see the helpful banner, GitHub telling us, hey, you pushed this branch. Do you want to do something with that? And we're going to say, yeah, actually, we kind of do. We want to make our pull request. But when we make this pull request, there's no template. What? We wrote a template. Y'all were right there when I did it. We did it together. It was great. It was a really good bonding experience. That template, though, is on our feat templates branch. It's not on main yet. So, as far as GitHub is concerned, the template isn't approved and therefore can't be used yet. So, we're going to have our blank pull request here to start. But if you remember in our template, we wrote that closes keyword and then the $sign and a bunch of X's. And we have some instructions in there to replace the X's with an issue number. We're going to do that here without a template. We're just going to make it work. We're going to write closes. We're going to hit the $sign. And we're going to get a list. GitHub is going to give us this helpful little list of our most recent issues and pull requests. Issue number 2 is a ticket to create issue and pull request templates. Our pull request includes all of that, so we can say that our pull request will successfully resolve that issue. So we'll pop a 2 in there. Then let's go ahead and create our pull request. We take a look and we see number 2 is now a link. If we hover over it, GitHub helpfully shows us this little card that gives us a quick overview of the issue. Our issue is still open, but we're going to merge this pull request. And when we merge this pull request, let's delete the branch because we're here, and we go back to our issues is gone. And our issue is gone because GitHub automatically closed it, because we used the closest keyword followed by the issue number to effectively say this pull request should close that issue as soon as it's merged, because it solves the issue. Beautiful. But does this stuff actually work? Let's find out. Let's click on New Issue and try to create another issue. Look at that. Our little menu that had 2 options now has 4, because we have 2 templates that we've defined. We have a feature request. We click that. We see our title. We see our description. It looks just like the template we wrote. Let's go ahead and fill this out. But we don't care about motivation. We're not motivated. It's too late in the evening for motivation. We can delete that. Look at that. It's gone. Never even existed. For the rest of these, let's just put in some emoji. Let's do some hearts. I think we need some hearts today. Let's put a heart there. And we'll put a heart there. And we'll put one there. And let's put a bunch there. And let's create our issue. We can now see our issue. All of those HTML comments have disappeared. You can't see them in the view. You see all of our beautiful hearts. But we were able to remove that motivation section entirely. That's kind of a problem if you want people to fill out a section and they can just delete it instead. Let's take a look at our bug report template next. We're going to go ahead and I found a spider, caught me in its web, click that, and now we have an actual form. And this is why I love issue forms so much and wish they were on pull requests too. Because we have our title, and let's say the bug is a mosquito. What happened? We see our title, our description. We see our value. If we come back to the file here, get out of my way. We see our what happened text box, our value a bug happened. If we delete a bug happened, we see our placeholder, tell us what you see. We can see our markdown component here. Thanks for taking the time to fill out this bug report. That comes from here. We can see our little asterisk here that says this field is required. But is it really? I don't know. Let's find out. We're going to leave that empty. Next, we have our browsers dropdown. Beautiful. We have options. Excellent. Do we have options? We do. Let's see. We found mosquitoes in Firefox. And we found mosquitoes in Chrome. And we found mosquitoes in Edge. But there are no mosquitoes in Safari because somebody brought Raid to that party. So we're just going to pick those 3. Then we have our relevant log output. And when you look at this, it looks just like our what happened box, except you don't get any of the markdown formatting. You don't get any of the markdown formatting because we told GitHub we want this formatted a specific way. Remember that we set it to render as a shell code block. So let's stick something that looks like a shell command in there. Let's say git clone URL. Cool. Looks beautiful. Then we have our checkbox here, our code of conduct. We have our title, our description, our link, because it is markdown and we could render a link. Let's tick the box. We followed the code of conduct. Sure. Now if we try to create our issue, look at that. Our field is required. We got to put something in there. Let's put a spider. Look at that. We have a spider. Yes, this is being recorded. It will take me a bit to get it edited and uploaded. I did upload the workshop number 2, which should have similar information in it. It's available in the announcements channel. And yeah, so you can view that, and I will make an announcement when I have these ones ready too. Let's go ahead and create this. There we have it. We have our beautiful issue. We have what happened. We have our spider. That thanks for opening a bug report markdown went away because that was just visible to the user filling out the form. We have the browsers we selected. And look, our little git clone formatted as a code block. Now, if we edit this, we can see that GitHub has followed our instructions and applied shell formatting. Beautiful. We have our code of conduct with our checkbox. Perfect. Excellent. Exactly what we wanted. Template works. What about the pull request template? You know what? Let's take a look. Let's go back to our code tab here. And we're going to edit our README. And let's put another spider in there. We need more spiders. We're going to commit our changes. We're going to call it spider. We're going to call it more spider. And instead of committing directly to main, let's create a new branch. GitHub's going to offer us my username, patch1, for the default branch title. That works. Good enough. Let's propose some changes. Now we're taken to the pull request UI, and you can see that our checklist from our template has populated. Let's fill it out. We read the contributing guidelines. We're targeting main. We did not test these changes locally. Granted, there's not much to test, but I prefer not to lie on pull request templates because it makes me look bad, so we're going to leave that box unchecked. This does not close any issues, so we're going to leave that alone, and we're going to make our pull request. And just like that, our template has worked. Again, you see the comments have disappeared, but the checkboxes are there, and we can go check them again after we test it locally. Let's say we tested it locally. We can check it. We change our minds. We lied. We don't want to get caught in our lie. Let's uncheck it again. Quick and easy to edit the checkboxes because you can click them. So that does bring us to the end of the workshop. This is a bit of a shorter session because anything else I would like to cover would take way too long. And I would like to make some space for you all to be able to ask any questions you might have. You can either ask questions by coming up on stage and speaking with me, or you can drop it in the chat. I do have the chat open. I can see it, and I will respond to your question there. I'll give folks a few minutes to pop any questions they might have, and then we'll take care of those and the screen share and call it a day. All right. Well, kind of a quiet session, which makes sense. It's the end of the week. I don't know about you all, but I have to work in the morning. So let's go ahead and call it there. I hope that this has been beneficial for you. You are welcome to use this repository to experiment, make issues, make pull requests. I don't care. It's a practice repository. I won't ban you for making silly pull requests to this repository. Maybe we'll want some more spiders. I love spiders. Let's put more spiders in there. If you have any further questions, by all means, please feel free to ping me in our Discord community. And as always, it's been real. It's been fun. It's even been real fun. We will see you all next time.